A very warm welcome to you, matriculants, grade 12. Thank you for joining this lesson. I go again by the name of Katlego, Nakedi, and I'll be going through a 2021 November question paper with a focus being on analytical and circular geometry. Okay. So we'll be doing a typical exam question paper. It's going to be question 3 and question 4. Just before we start, you'll see on the screen there are a couple of tips and guidelines that you can use when attempting or when solving analytical geometry problems. Okay, so very important that you know how to, you can't just walk into an examination without a strategy. So you should always have a strategy, and this is the strategy that you must apply on analytical geometry. Okay, so you can pause the video, take notes, and then you'll take it from there. Okay, I hope you've got your pen and paper, you've got your calculators ready, so that I don't only do these problems alone, but you also attempt to do them and see if you get the correct answers. Okay, and again, there are many ways to solve these problems. So it doesn't matter which method that you use, as long as the principle is mathematically correct and as long as you get the correct answer. Okay, now let's jump straight to question 3. So you will note that this question is for 24 marks. As mentioned, this is question 3 of the question paper that was written in November 2021. Usually with previous examination papers, what I've noticed is that question 3 will be analytical geometry from grade 11, and question 4, they will introduce analytical geometry from grade 12. So if you are a grade 11 learner and we are watching this video, the strong focus for you should be on question 3, and then when you get to grade 12 next year, you can start seeing what you will be learning when I'm doing this question 4. Okay. All right. So the question paper or the question for this problem statement for this question read as follows. In the diagram, we've got point A, we've got point B, we've got point C, and on it and are the vertices of ABC. So vertices means are points. All right. Line BC is produced to H cars there, and AC intersect A, the axis is at F and G respectively. The angle of inclination is 81 degrees. So there is your angle of inclination. Okay, so I'm automatically going to mark this triangle. I don't know how it's going to help me, but there's a reason why they told me about triangle A, B, and C. I'm just going to mark it. We'll see when we get forward in terms of what is going on here. Okay, something very important that I want to mention. You see they give me point B, which is K, which has coordinates K and K. The fact that this coordinates is K and K, it means the value that I'm going to get is the same. So if K is equals to -4, the X value, it will also mean that the Y value will be -4. Otherwise, if these coordinates were not the same, they was gonna maybe name one as K and the other one as Q to show that K and Q, the X value and the Y value, are not the same number. Okay, but in this case, we must just know that if it's K and K, the answer is the same. And you can see it's in the fourth quadrant. So is that going to be -4, -4, or 5, -5, and -5? We just know that our K value is going to be negative because it's in the fourth quadrant. No, not fourth, third quadrant, sorry. Your X value and your Y value are both negative. Okay, now let's solve the problem and we'll take it from there. The problem, question 3.1 says, calculate the gradient of BE. So question 3.1.1, gradient. We know the formula for gradient. Gradient for BE. Gradient is changing Y over changing X. So changing Y of B to E. You see what the examiner is doing. I like this problem. he's forcing you, or he's telling you about the gradient of BE, but you don't have the coordinates of K, of B, which is K and K, and you can see this is 2 marks. So you can't start by solving that. But because B, C, and E are collinear points, which means are points on the same line, which that also means that the gradient is the same throughout this line. So the gradient is the same on this line. So instead of using B, I can also use point C and E because I've got point there and a point there. So what I'm going to say, the gradient of BE is going to be 12 changing y over changing x, so 0 minus minus 2, so 0 plus 2 over 12 minus 4, and this is going to give me 2 over 6, 2 over 8, which is the same as 1 over 4. Okay, so that's your gradient for BE. So the examiner was very clever there. He strategically said BE, but you don't have the coordinates of B, so you'll be stuck there saying, how do I do this? But you forgot that C and E and B are collinear points, so it means the gradient is the same throughout. Okay, very important. 3.1.2, calculate the gradient of AB. So let's see the gradient of AB, how to that is A and that is B. Now I've got a problem. How do I calculate the gradient? Because I don't have the coordinates of B, which is KK, right? But something that is very important, they gave you the angle of inclination to AB, and we know that tangent of an angle in this case it's 81.87 degrees is going to be equals to the gradient of AB. Therefore, you can take out your calculator and find the arctan of this. You find that the gradient is equals to 7 degrees. Okay, very, 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 very important. So the gradient of AB is equals to that. All right, 2 marks. 3.1 or 3.2. Determine the equation of BE in the form y is equals to mx plus c. So we know that for us to determine the equation of a straight line, we need a gradient and we need 1 point on that particular line. So let's look at BE. Where is B? So we are still here B and E there. Okay, we already have a gradient which we found to be 1 over 4. We need a point on that particular straight line that we can substitute. You can either choose point C or point E, it's up to you. So I'm going to use the formula that says y minus y at C is equals to m into x minus x at C. Y, what is the y value at C? It's minus 2, so negative negative going to give me positive. The gradient I found it to be 1 over 4. The x at C, it's 2, it's 4, sorry, so minus 4. Therefore, when you simplify this, we'll find that y is equals to 1 over 4x, half of negative, this will cancel that, and then 1 minus 2 will give us minus 3. That's your equation of a straight line. Okay, equation of a straight line, BE. 3.1, calculates the coordinates of B. Now they are forcing us to find the coordinates of B where K is 0. So K is less than 0. What does it mean? It means the answer that you're going to get there is negative. And that's what I was saying, because I said this is first quadrant, this second quadrant, this is in the third quadrant. And in the third quadrant, both X and Y values are negative. That's why they're telling me that K is less than 0. How do we find that? Okay, no need to panic. There's a reason why they ask you to find the equation of line BE. We're going to use the same formula from BE and say the equation of BE is equals to 1 over 4x minus 3. What is my y value at? And I'm at at point B, right? What is the y value at B? The y value at B, it's k. 1 over 4. What is the y value? What is the x value at B? It's k minus 3. So I've got one equation with two unknowns. Sorry, I've got one equation with one unknown. I can solve it. I can find the value of k. So this is going to be 4k is equals to, this is 4k, k minus 12. 4k, take k on the other side, it's going to be 3k equals to negative 12. Therefore, k is equals to negative 4. All right? It's negative 4. Therefore, I can say the coordinates of B, it's k and k. It's going to be, the x value is going to be negative 4. The y value is going to be negative 4. All right? Beautiful stuff. 3.3.2, the size of angle A. Where is angle A? So they want us to find this. They want us to find this angle here. Now, many ways to solve this. How can I best do this? I'm going to focus on this triangle here. I'm going to focus on this triangle. I hope you can see the triangle, right? I'm going to extend into the exterior angle there, right? So the first thing that I'm going to do is to say, if I can find this angle, which is the exterior, if I can find this angle here, it will be the sum of the three opposite angles, and I've already have that, so I can find the angle of A. I'm gonna say, do I have the gradient of AC? No. So I'm going to start by looking to determine the gradient of AC. So I'm going to say the gradient of AC is going to be changing y over changing x. So it's going to be 10, but I don't have the coordinates of G. I don't have the coordinates of G, but if you look at G and C are collinear, are all on the straight line. So I can use C as my substitution. Very, very important. 10 minus 2, so it's going to be 10 plus 2. And then minus 2 plus minus 4. And this is going to give me what? This is going to give me negative 2. And it is very important. You see, it's negative 2. This shows you that my straight line, my slope is negative. It's bended to the backside. It's a decreasing function. All right. So it's also very important to always check your signs when you look at the gradient, because it doesn't make sense to be a positive or negative. All right. So that's negative 2. And then now that I found the gradient, which is negative 2, I can find I can say the tan of angle AGE. So it's AGE, it's this angle, which is equal to negative 2. When I punch this on a calculator, it must be an angle that is greater than 90 degrees. So the angle there is going to be the arctan the answer that you get, you're going to get negative 63 degrees, and you add 182 there, then it's going to give you 116.56 degrees. Maybe let me pull a calculator so that I can show you how I got that. So we can say a tan of negative 2 degrees, or no, of negative 2, and then we're gonna, for this answer, you're just gonna add 180 degrees. right? So that's how you get your 1156. Okay, where's my pen? Degrees. So now I have found this angle. So this angle is 116,56 degrees. But I know according to trigonometry, um, um, angle AGE is going to be the sum of the interior opposite angles, which is going to be 81,87 degrees plus the angle A, which is what we are looking for, all right? So I'm going to substitute this 116 plus angle AFG 6,56 degrees is equals to AFG 81,87 degrees plus angle A. Therefore, A is equals to 116,56 minus 81,87, and we're going to give you 34,7 degrees. Very important here to put a reason. Exterior angle of a triangle is equal to the sum of the interior opposite angle. Right, and that's how you get your angle there. 3.3.3. Coordinates of the point of calculate the coordinates of the point of intersection of the diagonals of the parallelogram ACES. Where is S now? Where S is the point in the first quadrant. Okay. So they're telling us that S is a point in the first quadrant, and it forms part of the parallelogram. So I'm just gonna take blue, light blue, say A, C, so I'm following this, C, E, S should be in the first quadrant, and it forms part of the parallelogram, so it's likely going to be somewhere there. All right. It's like if I had a ruler, I was gonna show you, but yeah, it's likely going to be a point somewhere there, so that this can form a parallelogram. All right. So this forms a parallelogram, and they're talking about diagonals of a parallelogram. So we know diagonals will run like that. Oh, okay, so I can do it straight line. Okay, let's try that again. Okay, so our point S is somewhere there. Now let's go back to understand what they want. Calculate the coordinates of the point of intersection. So where are they going to intersect? They're going to intersect here. So they want the coordinates then, right? So one of the properties about a parallelogram, which takes me back to what I mentioned here, 9, to say you need to know exactly the formulas that applies to the type of questions. So you also need to know the properties of the parallelogram: square, rectangle, rhombus, trapezium, and kite. All right. So you will know that a parallelogram cuts here. This will be a midpoint, because this point will be equal to that point, and that will also be equal to that. So this is the midpoint. So how do I find the midpoint? I can say I've got the coordinates of A, I've got coordinates of E, so I can find the midpoint. So that is very simple. I can say, what is the midpoint of line A, E? And we know that the midpoint, we say X value at 1. So minus 2 plus 12 divide by 2, and then what? And then 10 plus minus 2, sorry, 10 plus 0 over 2, and then this will give me what? The coordinates is going to be minus 2 plus 12, that's 10. 10 divided by 2, that's negative 5. 10 divided by 2, that's positive 5. So the coordinates is going to be 5 and 5. I just want to make sure of that negative. It can be negative here. 12 minus 2 is positive, so 5 and 5. So let me fix that. 5 and 5. Okay. Beautiful stuff. Now we're moving to 3.4. And it says another point T, which is PP, where P is greater than 0. Okay, so there's another point T where P is greater than 0. All right. Again, P and P is similar to that K and K. So if it means X value and Y value is the same, and they're telling me that P is positive. So the only quadrant where this can be valid is going to be in quadrant. It's going to be quadrant 1. All right. It's going to be in quadrant 1. So let's just assume that T is here. We don't know. We just know that it's going to be P and P, the coordinates, right? It's plotted such that ET is equals to BE. So wait, where is E? So they're telling me that from E to that point T, this line is equals to B to E. B, where's B? B to E. I'm sorry for this mess, but yeah, that's the best that I can do. So they're telling me that this line and these lines are equal. Okay, and they want us to find the coordinates of T. Okay. How can we solve this? Another point where P is plotted. Okay, and they're telling me that the length there is the 4 square root 7. So this is 4 square root 17 units. 4 square root of 17 units. I just want to read the question again. Another point T where P is plotted such that, okay, calculate the coordinates of. So if they give me these units here, what are they saying? What's your understanding? What does a length mean to you in analytical geometry? A length means distance formula. So let's see what will happen if we do apply distance formula on point TE. So let's say, what is the formula for distance? So TE, the distance, we use T squared, then I want to say X. I'm just gonna write the formula first so that we don't get confused. X at E minus X at let me start with T at xt minus X at E. Distance formula is it a positive or plus? Yeah, it's a plus because we are adding, and then Y at T minus Y at E. Okay. Now, what is the length from T to E? The length from T to E was given to us as 4 square root of 17 squared. It's equals to, oh, I forgot the squared here. What is X at T? X at T, it's that. So it's going to be P minus X at E, 12 squared plus Y at T is also P minus 0, yes, squared. So I've got one formula, one variable. I need to solve this. So This on the left hand side is going to give me 272. Then I'm going to FOIL this. This is going to give me p squared minus p minus 24. P 12 squared is positive 144. Plus, what is p minus 0 is p, then p times squared is going to be p squared. Right? Simplifying this, 72 is equals to, this is going to give me 2p squared minus 24p plus 144. I'm going to divide everything throughout with p, then I'll be left with p squared. I'll divide everything by 2, not p. P squared, and move everything on one side. 2p squared minus 12p minus 64 is equals to 0. Then I factorize this. The coordinates there is going to be 8. No, 64, 8 is not going to go through. Let's try 16 and 4, 4 and 16. The bigger number, take the sign of the middle terms. This is the bigger number. Therefore, p is equals to -4, or p is equals to 16. They say something p is greater than 0, so it means this one is not applicable, and our final answer is equals to 16. Okay, then you can say coordinates of t is 16 and 16, because they wanted us to find the coordinates. We must not only say p, we must show the coordinates. All right, beautiful. Let's move on. 3.4.2, determine the equation of the circle with the center at E and passing through B and T in the form of, okay. It's gonna get messy, apologies, but let's see. So what are they saying? They are telling me that there's another circle in this sketch here that is already there. And that circle has got a center as E. So there's my E. And the circle passes through the coordinates B and T. So the circle will pass here and here. So if I were to draw that, the circle would be like that. All right. And we'll pass angle T. Okay. So they told me the center. So we know that, okay, this is going to be 3.4. 3.4.1, 3.4.2. So we know they gave me a general formula with plus y minus b squared equals to r squared. So the coordinates of the center is going to be point E, because they told me that E is the center. So x minus E, x minus E, so this is A, x minus E, E is 12, x minus 12 squared plus y minus b is 0 squared. The radius, how do I find the radius? Remember, the radius of this, we already know that it's going to be 4 square root of 17. So 4 square root of 17 squared. And that is your answer. But maybe you can simplify this and say x minus 12 squared plus y squared is equals to, and 4 root 17 squared, we know that is 272. Okay, and that's how you conclude this problem. Last question, B. Oh my God. B. Determine the equation of the tangent to a circle passing at point K, point point B, K and K. So what are they telling us? They are telling us that remember this purple uh, circle of mine. They are telling me that there's a tangent passing through there, right? So this line is a tangent. Oh, okay. So obviously, if it's a tangent and they want the equation, so we know that the equation is going to be in a form of y is equals to mx plus c, right? So we need the gradient of that line and we need a point. Now, what is the gradient at point B? How do we find the gradient of this line? Very important to note that line BE, this line BE is going to be a radius of this imaginary circle, right? So, and we know that the radius is perpendicular to tangent, okay? And then we've already determined that the gradient of line BE is equals to 1 over 4. So the gradient there is 1 over 4, which means the gradient of the tangent is going to be -4. How do we find this? We know that gradient of a tangent is when you multiply the gradient of the radius is equals to -1. All right, and then we know that the gradient of the tangent is gradient of the tan multiplied by the gradient of the tangent, which is MBE, is 1 over 4. So we can hear radius perpendicular to tangent. Okay. Therefore, the gradient of the tangent is going to give us -4. Now I need a point where that line is passing, and it's passing at B. And we know that the coordinate of B is what? -4 and 4. -4 and -4. Okay, so I'm going to say y of the tangent is going to minus what is the point at B? Minus going to be 4 is equals to the gradient is -4. X, what is the x value at point B is going to be -4, so negative is +4. Therefore, when you simplify this, you'll find that y is equals to -4x -20. And that is the equation of a tangent line passing at point B with the coordinates k and k. So the -20, yeah. Okay, what a question. I know it was messy, but I'm happy when it's messy, but it makes sense. Okay, beautiful. We've collected our 24 marks and we now going to collect our 15 marks. So grade 12s, brace yourself. If you're in grade 11, from question 3.4, that's where you need to, let me see, actually from, yeah, if you're in grade 11, from up to here, this is all the way up, that's grade 11. Then this last question is grade 12. Okay. Now, question 4. Question 4, you read the problem statement and then you can resolve the problem. Okay, so I see parallel lines there. I see parallel lines. I see parallel line. I see point C, D, E, B. Okay. It's a circle with a center N, -1 and 3. All right. what is this parallelogram. So they don't tell us what is this parallelogram. Oh, they don't tell us, or they tell us what is this quadrilateral. The quadrilateral is a parallelogram. Okay, parallel. So if this is parallel to the, such that BE is parallel to the x-axis. So BE is parallel to the x-axis, which also means it passes there. Okay, which says this is a gradient, this is a straight line. All right, no, it's fine. 4.1, write down the length of the radius of the circle. Write down the length of the radius. So let's see. So if this is the point there, and I'm looking for the radius, I can go there and say, this is my radius. Okay. Now the question is, how do I find this radius? We know that, so because I'm moving in the y-axis, I'm going to say my radius is going to be y. So from 4 to -1, I move 4 units. Do you agree? So I can say my radius, 4.1, is going to give me my radius. It's 3 minus into -1, which will give me 4 units. You can also use the distance formula. You will see that it will automatically give you 4 units. All right. 4.2.1, calculate the coordinates of C. So you can see that C and A, how do we know that C and A are on a straight line? We are not sure. So what we know from this is that the y value, where it cuts the y-axis, is going to be, okay, let me go in and understand what is this 6 mean. Or 6 is 6 units, it's not the length. Okay. Okay, how do we get to C? C is also a point there on the circumference, right? So the y value at C is going to be 3 plus the radius. So 3 plus 4 is 7. So the y value will be 7. And then the x value is -1, because we can see that this is all on a straight line. Okay, so -1, -1, and 7. Calculate the coordinates of D. Calculate the coordinates of D. Where's my D? So we want the coordinates there. Also for 2 marks, so we got that, so we are here. Calculate. All right. Okay, so if my coordinates here, it's -1 and 7, and I move 6 units to the right, so it's going to be, D will be 7, and I'm moving in the horizontal, so I'm looking at the x-axis. So my x value is -1 at C, then I need to move 6 units to the right. So it's going to be -1 plus 6, which is going to give me 5. Right? So automatically my x value here is 5. And how do I know that it's a straight line? They told me that this is a parallelogram, and they told me that this is parallel to that and also parallel to that. So that's why I know this point is just, this C and D are on a straight horizontal line. Now, how do I find the y value? The y value doesn't change. It will remain 7. Basic analytical geometry from grade 10 or even grade 9. Okay. Now they want us to calculate, 4.2.1. So it's 4.2.1. They wanted the coordinate of C. Coordinate of C is what? 6 minus 1 and 7. 4.2.2. The coordinate of D. I said the coordinate of D is 5 and 7. 4.3. The circle with center N. Okay. So center N, is reflected about the y is equals to x. M is the center of the new circle which is formed. The two circles intersect at A and B. Okay, now let's see. So this point, the point will be reflected about the line y is equals to x. So we know that the line y is equals to x, it's like that. Okay, so if this point will be reflected about this line, this point here will come somewhere there. So this point has shifted and it's now here. Okay, now what does that mean? When you reflect about the line y is equals to x, your x value becomes your y value, your y value becomes your x value. Okay, so your x value on n was -3, it will mean it will become your y value, -1. Your y value was 3, and when it comes here, it's going to be an x value, which is going to be -3. Sorry, 3. Okay. All right. So this is my coordinates of m. The x value is 3, and then -1. Actually, don't need to show this line. I was just wanted to show you earlier. So we know that our center is now coordinates, our new circle is coordinates 3 and -1. Okay. It was just reflected. It was not enlarged. It was not reduced. It was just reflected. So it still has the same radius. Okay. It just shifted or reflected. The two circles intersected A and F. So where's my A? A and F. Where's my F? I don't know where F is. They didn't specify. Did I? Circle is formed. The two circles intersect at A and F. Just want to see where F is. Okay. We'll come to that, but I just know that A is here, so F it could be anywhere, because that circle, it will have all right, so we'll come to that. 4.3.1. Calculate the length of NM. So they want the length from N to M. This line. Since I've already shown, so we're gonna start by saying the points, the new midpoint of the new center, the center of a new circle that has been reflected about the line y is equals to x is going to be 3 and -1. I see there's something that I've missed. I missed question 4.2.3. I will come back to it. Because now we still have the momentum of 4.3. Sorry about that. Okay. We'll come back to that. For now, I want us to calculate NM. So we found that M is 3 and -1. Those are the coordinates. And then distance formula, because this is a straight line. So NM is going to be, if you apply your distance formula, it's going to be between N and M, -1, -3 squared plus 3 minus squared. And the answer there is going to be 4 square root of 2. Okay. 4.3.2, the midpoint of AF. Okay, let's go and check. Where is A? A and F. So again, they are bringing us, they are taking us back to that F. All right. Let's go back to drawing the circle. So the new circle, if we were to imagine it, let me see how will it be. So it was likely going to be something like this. It's going to be something like this. The new circle. Okay. So I think that's where F will be, because they told us that the two circles, so circle 1 and circle 2, intersect at A, which is A there, and F, but they don't tell us what is the coordinates of F. All right. Now they want us to find the midpoint of A to F. So they want us to say from here to there, what is the midpoint? Or if this is the midpoint, what is the coordinates? All right. But we can't do that if we don't know what is the coordinates of F. So we need to find the coordinates of F. All right. So if they're telling us that these two points intersect, it means we can solve this simultaneous. Right? How do we do that? The first thing that we're going to say is for a circle with center. So I'm just going to say for a circle with center N. So I'm looking at the first circle with center N. I know one thing. I've got x minus 1 squared. So I'm just applying my distance, not my distance, my equation of a circle. So I'm looking for the equation of the circle with center N. Okay. Remember, N is negative. That's why it's plus. It's negative, which is plus the plus y minus 3 squared. What is my radius? My radius, I found it to be 4. So 4 squared is 16. Okay. I can simplify this. Or it's fine. I'm going to leave it here for now. Then I'm going to go for a circle with center N. All right. I'm also going to find the equation. So this is my equation 1. And then this is too big. X minus 3 squared plus y minus minus is going to be y plus squared. It also has got the same radius. How do we know? Because it only reflected. It didn't become small, it became bigger. It only reflected, so it still has the same radius of 4 units. So 4 squared is going to be 16. So this is my equation 2. Now I've got 2 equations with 2 variables. I can solve this simultaneously. All right, back to algebra. It's up to you how you want to do this. Okay, I was looking at this. Actually, we can even have a third equation here, because what do I mean by third equation? Look at point A and point F. What is happening on point A and point F? You've got circle 1, got circle 2, and we also have got a straight line, y is equals to x. So you can also say we also have got y is equals to x. This is equation 3. So at where these 2 points, where these 2 circles intersect, there's also a straight line, which is the same straight line that reflected this second circle about the y is equals to x-axis, right? Or maybe let me repeat that. So we've got circle 1 and circle 2. This circle 1 and 2, they intersect at point A and F. But at the very same point A and F, there's a line that is passing through there, which is y is equals to x. Okay. That's why it was very important. Going back to my guidelines, it's very important. Point 1. Always draw by plotting or sketching the points or labeling them correctly. A clear diagram helps you visualize the problem and identify the correct method. Okay, so that's why now, because I drew the line y is equals to x, I'm able to see that, oh, okay, there's also a line that is passing there. All right, so I can say substitute equation 3 in equation 2. You can substitute in 1, it's up to you, but so it means where I see x, I can substitute y. All right, so x minus 3 squared plus y plus 1 squared equals to 16. So where I see y, I can substitute x. So I can say this is also y, and then I can simplify this. It's going to give me y squared minus 6y plus 9 plus y squared plus 2y plus 1 minus 16 is equals to 0. Y plus y is going to give me 2y squared, and that I'm done. Minus 6y plus 2y is going to give me minus 4y. And then 9 plus 1, that's 10. 10 minus 16 is going to give me negative 6 equals to 0. Going to divide throughout by 2, divide by 2, divide by 2, divide by 2, divide by 2. This is going to give me y squared minus 2y minus 3 is equals to 0. Factorization, y, 3, 1. The bigger number take the sign of the middle term. The bigger number is 3 minus plus, therefore y is equals to 1 or y equals to 3. Now let's pause here and analyze this. What does this mean? It means that we've got two y values, okay? Therefore, I'm going to say substitute, I'll come back to it, substitute y into, oh, okay. But we know that y is equals to x, so this is not necessary. We know from here that y is equals to x. So what does it mean? It means that this is also x is equals to 1 and x is equals to 3. So we've got coordinate here and a coordinate there. Let's go and see what is happening. So that this was supposed to be negative, 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 and then this one positive, right? Now look at this. The coordinates, so we've got coordinates here and negative 1 and negative 1. Then we've got a coordinates here 3 and 3. What does it mean? Coordinates negative 1 and 1 is what was given to us. We know that this is point A, then it means this will automatically be point F. So the coordinates there will be 3 and 3. Beautiful mathematics, the beauty of mathematics. Now I can go back and say, for me to find the midpoint, I know that the midpoint is going to be the midpoint of AF is going to be minus 1 plus 3 divided by 2, again minus 1 plus 3 divided by 2. Therefore, the midpoint of AF is what? It's 1 and 1. So it means this point here is 1 and 1. What a question. 4 marks. Yeah, you were supposed to sweat for this 4 marks. Okay, now let's go back to 4.2.3, which I mistakenly forgot. They want us to find the area of triangle triangle BCD. So remember I missed here 4.2.3. They want us to find the area and it's for only 2 marks, so which means it's easy. Area of triangle BCD. Now let's go and highlight BCD. BCD. Okay, so they are forcing us to say there's a line that is going there. Okay, so they want the equation there. Oh my goodness, now it colors makes the diagram looks beautiful and makes it easy for you to analyze. So they want the area of B, C, and D. Okay. Now that we know that areas given by half, base, times height. What is the base in this case? Our base is going to be, because this thing is like this. So this is going to be, but wait, I need a perpendicular height. Where is the perpendicular height? Okay, so my base is going to be line CD. CD was given to me as 6. And then perpendicular height, just wanna check. There's that 5 units that your perpendicular height will be that. So from there to there, and we know that this is 5 units. So perpendicular height is going to be 5. And then when you simplify this, it's going to give you 15 units squared. Alternatively, what you can do, you know that area, okay, it's going to be, alternatively, this is going to be area is equals to half base, half of CD multiplied by B, what else that point on top, BC, sine of the angle included, which is sine C. So if you can find, you've got CD, you've got B, you can find BC using distance formula, then, but now you'll have to find the angle there. That angle will be 90 plus something, the smaller angle. And then, yeah, that will also give you 15 unit squared. So there are many ways in which you can solve this. But yeah, in this case, fortunately, I was able to see the perpendicular height, right, which is 5 units. Similarly to your, how do we get that 5 units? It's going to be 6 minus 10, yeah. Okay, apologies, grade 12s. This was a messy diagram, but it was a very interesting and exciting question. Again, I invite you to do this problem on your own and see if you're gonna get the same answer. I thank you.